Good afternoon, and welcome live to NASA's Kennedy Space Center in Florida. I'm Megan Cruz, and you are watching the Space Station 101 panel ahead of NASA and SpaceX's Crew-9 launch. We are currently targeting tomorrow, September 28th at 1:17 p.m. Eastern Time to send astronaut Nick Hague and Roscosmos cosmonaut Aleksandr Gorbunov to the International Space Station. Once there, they'll be part of Expedition 72, where they will help to maintain the orbiting lab and conduct groundbreaking research there. But some of you might be asking, what is the International Space Station? How does it benefit us here on Earth? So basically, it's a big research facility just 250 miles above the Earth. And really, if you think about it, that's not very far at all. That's basically where we are to Savannah, Georgia. So very close. And that's why we call this area in space low Earth orbit. The space station is about the size of an American football field and has the living space of about a 6-bedroom home. So there's a lot to learn about the space station and, again, how it benefits us here on Earth. So for that, I have this great group of people with me. So I'll start to introduce them now. To my left, we have Jim Free, NASA Associate Administrator. Next to him, Robyn Gatens, Director of the International Space Station and Acting Director for the Commercial Spaceflight Division at NASA headquarters. Jennifer Buchli, Chief Scientist for the International Space Station Program, as well as John Posey, Dragon Lead Engineer, NASA's Commercial Crew Program. So thank you all for being here. You guys are all expected to give some opening remarks in just a second, and then we're going to open it up for questions. So those here in the room, we have some reporters, some digital content creators in the room. Just raise your hand, and a mic is going to make its way to you, so just wait for that. If you're dialed in on our phone line, just hit *1 to get into the question queue. You can also submit your question with the hashtag #AskNASA on any social media platform that you're watching us today. Okay, so Jim, let's kick things off real hard, okay? So what is the International Space Station and why do we have it?
Well, thanks, Megan, and good afternoon, and thank you all for being here and for your commitment to further understanding what we're doing on ISS and just your interest in ISS and NASA, and I know this is a commitment in many ways of your own resources. And it's really great to know that there is interest now. It's hard to believe, but until a number of weeks and months ago, that folks weren't even aware of what our crews are doing on ISS. So I'm really happy that the folks up here with me will share the details of that. I get to talk to you kind of at the top level. And ISS is really a marvel of humanity. In 1998, the first two elements met in space for the first time after being built thousands of miles apart, which is an engineering marvel in and of itself. And since Expedition 1, Expedition is what we call, Megan mentioned Expedition 72. That's what we call each group of crew members that go up there for their duration and do the incredible things you're going to hear about today. But since Expedition 1 in November of 2000, the station has been continuously inhabited by people with rotating crews of astronauts. And if you think about that, folks graduating from college today, their entire lifetime, there have been people living off the planet and working there and pushing science and exploration further. And today the station is busy with visiting spacecraft, delivering cargo, crew, and private astronauts, with spacewalks for upgrades to the systems on the space station, with science investigations and technology demonstrations, with public outreach, and with commercial activities as well. Station's contributions to humanity and the importance of the work we do in microgravity come down to 4 areas. Science, that benefits from that low lack of gravity environment or microgravity, the orbit that it's in and the flexibility that provides to the scientist. Second is research that'll enable us to send humans farther into space for longer durations. It also fosters a growing space economy and strengthens our international partnerships. From medical research on drugs and cancer treatments to earth science instruments that collect climate data and record storms, appropriate, and volcanic eruptions in real time, deploy CubeSats, help us with space science research. The orbiting laboratory is a unique platform that benefits people on Earth in many ways. Robyn and Jen will talk more about the science and research and what the crews do, how we're cultivating new commercial capabilities. So let me say a few words about international partnerships. One of the station's greatest contributions is as much a human achievement as is a technological one. The ISS global partnerships exemplify how countries can work together to overcome complex challenges and achieve shared goals. The space station is managed through a collaboration of 5 space agencies representing 15 countries. More than 1 countries have used or are using the orbiting laboratory today, and astronauts representing 23 countries have visited the space station. As NASA continues to lead the way, we're already carrying many of those relationships forward through our Artemis campaign to explore parts of the moon yet to be explored by humans. Now in its 3rd decade of operations, the orbiting laboratory is truly helping the agency fulfill our mission by exploring the unknown, innovating for the benefit of humanity, and inspiring the world.
Thank you for those opening remarks. Jim, let me just ask you really quick, you mentioned the Artemis campaign. So how is the International Space Station helping us to achieve that goal that we're hoping to accomplish with the Artemis campaign?
I'd say in 2 ways. First of all, we've proven that we can work together on challenging technological feats, never to have been done before in history, in human history. And we're working together on those there, which tells us we're confident we can do that in the future. Helps us really go together. We're going back to the moon differently this time. We're going as an international community. And then, I'll add a third, even though I said 2, is it helps us really bring more of the skills from across the world together to understand and get to those Artemis goals that much faster.
Yeah, absolutely. I mean, if you think about it, the International Space Station is a test bed, right, for us to think about what it is we're going to need to figure out as we go farther and farther into our universe, and that is our Artemis campaign. So to that end, Robyn, again, this is an orbiting lab. What does it take to operate and maintain this lab? I know we depend on our crew on board.
Exactly. Great question, Megan. So we have operations 24/7, 365 days a year, and as Jim mentioned, over 23 years going like that. Never a day without a crew on board the International Space Station for over 23 years. So that's an amazing accomplishment. And there's a lot going on board the station all the time. It takes not only the 7 crew normally on board, but all the ground teams from across the NASA centers, our international partners, our industry partners, operating the payloads and working on the engineering, packing the next vehicle that's going to go up to do these continuous operations. So we really rely on that ground team from across the country and across the globe to support the crew on board station. So we currently have 9 members, 9 crew on board the station, and 2 more joining them with the launch of Crew-9, so we'll be up to 11, and then after a Crew-8 departs, we'll be back to our normal 7 crew on the International Space Station. As Jim mentioned, we're in Expedition 72, so think of it as a mission, and we're on our 72nd mission, and every time we rotate the crew out, we start a new expedition. So that expedition began on September 23rd when the Soyuz spacecraft departed and undocked from the space station, and that's when we change our pins. I don't have my 72 on today, but we change our pins and we start the new expedition. So this mission is made up of crew that launch on both the SpaceX Dragon, which is going to be launching hopefully tomorrow, and also our Soyuz spacecraft. And while those vehicles are on board, they stay docked to the station so that in case of an emergency, those crews can return safely to Earth on those vehicles. As Jim mentioned, we've had 280 people representing 23 countries that have visited the International Space Station. And so it's really a global effort involving thousands of people across the world. And while they're up there, they conduct lots of research, they take care of the station, they manage the comings and goings of all of our what we call visiting vehicles, those spaceships that bring up supplies. They do EVAs to go outside and do various activities, install new equipment or repair something. And they also have personal activities. We have the crews exercise 2 hours a day to maintain their health. And they also have meal time, sleep time, so very busy, but also some downtime too.
Yeah, downtime's really important. One thing I want to just add, Robyn just mentioned the Soyuz spacecraft. So throughout the life of the International Space Station, astronauts and cosmonauts have visited the space station through 4 spacecraft, right? So we have the Space Shuttle, we have the Soyuz spacecraft, and the SpaceX Crew-9 and Boeing Starliner. So again, those are the different kinds of spacecraft that have taken people to the ISS. Now, Robyn, you mentioned downtime. I'm glad you mentioned that because, yes, we do ask our astronauts and cosmonauts to do a lot to operate and maintain the station. So what time, when they do have downtime, what do they do?
Well, they can call their family. They can, of course, they gather together and they eat food. And I have some examples actually right here of some of the space food. And I think we have some samples to pass around to you guys to see what this looks like. So this is how food is sent to the station. It's prepackaged, and they add some water and heat it up, and it's pretty good stuff. This is sweet and sour chicken. We've got mac and cheese up here, some rice pilaf, and some cookies. Jim wants the cookies.
Jim's hungry. It is lunchtime. Thank you guys for joining us for lunch. We're passing around your samples now. Do the astronauts get to choose what meals go up with them?
They do. They get some personal preferences, and then we send up some standard items. We also launch, usually with every cargo ship, we send some fresh food, things like pizza kits and fresh fruit. And we also grow some food on board. We've had some crops growing on station, and the crew really loves to do that and to be able to harvest those crops. Sometimes we even send ice cream up. So they get a wide variety.
Yes, you are making us hungry for lunch, Robyn. Thank you for that. Everybody in the room now, if you want to take a look at the screens just right behind you here on the top, we're going to show you some photos of the crew hanging out, right? We talk about having some downtime. Robyn, can you talk us through some of those photos?
Yeah, there's 2 of our crew. There's Tracy and Sunny, and I think they're having a dessert there in the foreground. Yeah, things that stick together are good so they don't float away. I held up the cookies. It's a funny story. We have to be careful with crumbs on board the station because they can float and get in someone's eye. So things that are kind of hold together are better. This is a picture of our Expedition 68 crew dressing up as video game characters for Halloween. Next one. Yep, this is Megan MacArthur, and she's having some downtime reading in the cupola. This is a favorite hangout area for the crew. They love to spend time in the cupola and look at the Earth and take pictures of the Earth. And then this is Expedition 69 having a chess match with Mission Control. There have been crew members that take up musical instruments and play their musical instruments on board, so watching movies, so all these different activities. But they are quite busy with the science as well.
Yeah, and that's a great segue actually now to Jennifer, again, Chief Scientist of the International Space Station Program. Why do we do science and research in space?
We do science and research in space for a couple different reasons. One being the unique vantage point that we have in the International Space Station, and then the other also being that when you remove gravity from the equation, it allows you to look at your science in a different way. So talking about our vantage point, we do science that's looking out into space. So, for example, this particular crew is going to be repairing NICER, which is one of our astrophysics instruments, which is taking a look out as an X-ray telescope at neutron stars. We look down back on the Earth, so it tells us a lot about our own home planet. The space station covers 90% of the Earth's inhabited surfaces, so it gives us a really good picture of how our planet's changing, as seasonal cycles occur, what's happening with the ecosystem of our planet. And then I talked a little bit about how when you remove gravity from the equation, it lets you look at your science a little bit differently. So the crew's really busy with science inside the space station as well. Every increment, we're doing about 200 to 250 investigations. The crew is looking at things like fluid physics. They are performing cancer research. We've had a number of drug studies on board. They're doing things that benefit us here on Earth. So as I mentioned, we have done things like protein crystal growth. What we see in space is that you're able to grow purer and larger crystals. So that's a very successful area of research we do on the International Space Station to help with pharmaceuticals. They also do a lot of exploration research. So they help us with things like testing hardware that we need for missions for Artemis as well as Mars. And then we talked a little bit earlier about plants. And so we also do plant experiments for exploration as well as for food. Today I have with me one of our plant carriers. So this is a science carrier for our advanced plant habitat hardware. We have a couple different facilities on board that the crew can use to grow plants. We've done everything from zinnias to Arabidopsis, which is a very model organism research intensive plant. We've done radishes. This particular crew, this increment's going to be growing red romaine lettuce.
And the crew's part of the experiment too, right?
They are, absolutely. So we also do, the crew is part of the experiment, both with the pick and eat for plants, but then the crew members themselves often volunteer to be part of our human research program. And so this is crew members consenting essentially to act as test subjects, so we learn more about what happens with the human body and physiology in space.
Mm-hmm. And specifically back to food, I mean, growing plants, yes, gives us a food source, but also there's a psychological effect there that, the astronauts really take away from as well.
Oh, absolutely. I mean, I think a lot of us in the room probably learned that during COVID too. How many people became gardeners or we saw everybody's home filled with plants. It really brings the crew a lot of joy to be able to do that type of science.
Absolutely. So a wide variety of science and technology demonstrations that happens on the orbiting lab. And again, we do that because we do have crew that come up and visit the space station for these 6-month missions, right? So let's go to John now. So again, we're talking about this next rotation, NASA and SpaceX targeting again tomorrow afternoon for the Crew-9 launch. So talk to us about your role and when it comes to these visiting spacecraft like the Crew Dragon that go to the space station.
Absolutely. Thanks, Megan. Yeah, so very excited to be here. Lead engineer for Dragon on Commercial Crew, as Megan mentioned. So the Commercial Crew program has the awesome responsibility of bringing our astronaut crews up to the space station so they can do all that awesome science. My particular role as Dragon lead engineer, so the NASA spacecraft engineering team and I work day to day, hand in hand with SpaceX and our other commercial partners like Boeing to prepare the spacecraft and for the flights to the space station with the crew. So it's a complex but very fun and rewarding job to get to see our crew up in space, having fun and enjoying the ride when they get there.
And how challenging is it to have different vehicles that go up to the space station?
Yeah, so it definitely presents a challenge, right? So one of the amazing things about the Commercial Crew program is that the commercial focus, right? It's a lean, mean program on the NASA side. We work directly with commercial partners on their designs for their spacecraft. And so that lets us have a focused view of what those spacecraft interactions are like on the NASA side. So we can work with them to ensure that they meet our requirements, that we've got all our safety aspects met, but then we can see the innovation of commercial industry and getting us there effectively, quickly, making improvements to design and safety, oftentimes maybe faster than what NASA may have experienced in the past. So we love to realize those benefits and see that be incorporated in the vehicles that we fly.
Yeah, and Jim mentioned this before, cultivating this commercial low Earth economy. Can you talk to us a little bit about that? What does that mean?
Yeah, so just, at a high level, we want to be one of many customers for spacecraft, right? And operate in low Earth orbit and for commercial enterprise to be able to take off. And that will, of course, yield economies of scale benefits to NASA as well. So for us, we're already seeing that with the Dragon spacecraft flying commercial missions as well as NASA crewed missions. And in some cases, really getting to push the envelope and test out new capabilities, like with the Axiom and Polaris missions that SpaceX flew recently for Polaris Dawn, which was exciting to see.
Great. Of course, please, yeah.
So, and I want to highlight John, and the team, the engineering teams. We bring NASA's expertise to the table. We have years of expertise of understanding flying humans in space. NASA started many years ago with a commercial cargo program to foster that economy, which turned into the Commercial Crew program. And John and his team that interact with Boeing or SpaceX are bringing all the knowledge that we've had from shuttle, that we have from ISS, and that we have from Artemis to bear to help that commercial economy come along. And we're pushing those commercial services onto Artemis as well.
Yeah, absolutely.
I'd
Guys,
also add, we have a number of commercial facilities on the International Space Station inside. And so that's another way that we are helping commercial industry develop these capabilities that then will be used in the future on commercial space stations. So things like we have a commercial airlock and a 3D printer, for example. So we have a couple dozen of these commercial facilities facilitating the research itself.
yeah. As you can see, guys, we can keep talking and talking and talking, but we do want to turn this over to you now. If you're in the room and you have a question, please raise your hand. Oh, we have many. I saw you here first.
Hi, I'm Jim Siegel with Florida Media Now and also O'Connor Space Deck. A question for Robyn. Robyn, you mentioned the idea if something happened in an emergency, the vehicles were docked and ready to take the astronauts off the ISS. Suppose there was an emergency. How long would it take for the astronauts to scramble to get into that spacecraft and to push away from the ISS? Are we talking about 10 minutes or an hour or 5 hours or what? Thank you.
Yeah, I think it's on the order of less than an hour, right? It depends on what the emergency is. First of all, that's sort of our last resort, and we've never had to decrew the space station because of an emergency. I'll just point that out. We have a lot of systems in place on board the station and redundant systems that will take over if something fails. We have the ability for the crews to go outside on a spacewalk and repair something in order to keep operations going. So leaving the station is kind of the last resort. There are a couple scenarios where that could happen, a rapid loss of atmosphere, such as a large leak or a fire, for example, or maybe one of the crew members becomes ill. And in that case, that crew needs to return home. And so it depends kind of on the scenario, but there are procedures in place for the crews to kind of scramble quickly to their lifeboats and get away if necessary.
Thank you for that question. Over here.
Thank you for taking my question. My name is Jean Wright, representing Space Up Close. I used to be a thermal protection seamstress on shuttles, so I found out that we have a new product that was developed by DuPont called Kevlar EXO. It's 40% lighter than conventional Kevlar, and I hear that they'll be sending 2 by 2 inch samples that would be glued and adhered on the outside of the space station to protect the new test for fabrics to protect against space debris. Does anybody know anything about that, or how it's going to be adhered, and how long will the samples be out on the ISS? Thank you.
Yeah, I'm sorry, I don't have the specific details on that investigation, but we do test a number of different materials outside the International Space Station. It's a great test bed to expose, as you know, materials to vacuum, atomic oxygen, as well as micrometeoroid debris.
All right, over here.
Thank you. My name is Pablo Fuente, coming from Spain for Radio El Respeto and NASA Social. My question is for Catherine. With an estimated cost of $3 billion a year and the amount of experiments you guys are running, why do you think that wide benefits like research done for sarcopenia or for osteoporosis that will benefit the whole humanity, people are not so aware? When you do the math, $3 billion for 7 billion people is nothing, and it's something that will benefit us all, men, women. Do you think you guys are conveying the message in the right way, or what else can we do from the social perspective to widespread that important research that you guys do. Thank you.
Thank you for the question. I think we are trying to convey the message, especially about the science and the research we're doing. We do publish our benefits for humanity. That's something that we don't do every year, but every several years where we try and highlight just some of those cases. It's really difficult to talk about how much research we have on the International Space Station. As I mentioned, we, in any given 6-month period, have 200 to 250 investigations. I think, sometimes some of the challenge can be how long it takes from when we do the research to the actual publication of the data, and then for medical research implementation into the clinic and into the patient. We've seen a number of success stories, but over that time period, maybe some of the original messaging gets lost. So I appreciate your question. It's definitely something for us to think about and how we can communicate that a little bit better.
If
We-
you don't mind me adding, Jen, because you're as a scientist, I think I'm an engineer. So when I hear about the science that we're doing, on the ground, we can grow tissue in 2 axes, in 2 dimensions. In space, we can grow it in 3, which is game changing not only for the tissue growth, but for understanding how medicines can help tissue differently. And to me, that is just astounding to think of how the environment of microgravity, which is only available in space, is just one small, and I have no idea how the long-term science effects. That's what Jen is excellent at. But to me, that's just as a human being, astounding that is what we can do, and figure out how the treatments can help us by growing the tissue, treating it, growing the medication in orbit in 3 dimensions as opposed to just 2, and how it can maybe attack things like cancer in the future. That's why I think our administrator has put us on the cancer moonshot that the president has started a year or so ago. So.
No, thank you. I appreciate that. And that's just a subset of what we're doing on the International Space Station. We've done to date around 4,000 investigations and served over 5,000 researchers. So we've got a great science communication team who helps us talk about those results and about some of the work going on.
And you can help us. That's why we're kind of here today, to reach people that, new folks that can help spread the message.
And just, before our cargo and crewed missions, we do have briefings like this where we do talk about the science and what the astronauts will be working on. So we always invite you guys to come and take part and ask questions. We love the opportunity to talk about what we do. Okay, here you go.
Hi, Ken Kramer, Space Up Close. Thanks for doing this. This is a different kind of briefing, and I'm really glad you were able to do it. So you brought up the spacesuits and the EVAs a little bit. Now, NASA's had trouble this summer, 2 scrub spacewalks. I wonder if you could give us an update on the repairs to the spacesuits. Where do we stand on that? And Butch and Sonny are up there, and they were EVAs and could potentially help out with that. So if you could give us an update, they're ready to go or need more work? Thank you.
Well, Butch and Sonny have been busy, and we're going to keep them busy. They're going to become part of this Expedition 72 crew and stay until February, and they're all set to go and have already been very busy. So the 2 EVAs we had to cancel. One was because of a suit discomfort issue. It wasn't a technical problem with the suit per se. And then the other issue was a leak in the, call it umbilical. It's basically a hose that attaches the suit in the airlock. And this has happened before. There's a connection that was leaking. It wasn't a serious issue, and that has since been repaired. So we've got some EVAs lined up. We've just been waiting for this very busy time when we've been returning Starliner and getting Crew-9, and then we're going to schedule those EVAs later on this fall. So the suits are in good shape.
And again, EVA's extravehicular activity, so spacewalks is what we were talking about. Go ahead over here.
Good afternoon, Jordan Wright, the Angry Astronaut. This is for Jim Free. In regards to Starliner, I think we can both agree that it is not yet an operational part of the Commercial Crew program just yet. given the fact that we're looking at maybe a total of 10 missions between 2026 and the deorbiting of the station, 5 of those may be going to Boeing, and that's optimistically speaking if Starliner becomes operational by 2026. At what point, or will there be a point, where NASA decides enough, we're not going to keep trying to push Starliner into this role given the relatively limited number of missions that are left, or are you going to keep pushing this all the way up to the point where the ISS deorbits?
Jordan, thanks for the question. You know, we had a lot of successes on Starliner. And I had a discussion earlier this morning where this chart popped up and my eyes went to the red right away. And there was a ton of blue, and in this case, the blue was the good on the chart. And Steve Stitch and others have talked about the successes that we had, right? We got the crew up there. The vehicle performed thermally, performed well. Yes, we had helium leaks. We had some thruster problems. We got the crew there. We docked, which is critical, again, for Orion because Orion's using the same docking system, the system that latches up to the space station. We got the vehicle back, right? We understand. We got the crew module back. We're looking at the data for the whole vehicle, the whole spacecraft, the crew module and the service module. We understand what happened with the thrusters. We need to spend some more time doing some testing. We're a long way from saying, hey, we're writing off Boeing. The success that we had with Starliner, the Boeing Starliner, I'm very proud of what we had. Our teams, the Boeing team, John and the commercial crew team worked excellent together. There's always things that we need to continue to improve on our teamwork. We'll continue to work on that. We're going to look at all the data that came back from this, look at how it compares to OFT, the first and second flight of the Boeing Starliner, this one being the third. So I think we're a long way from that.
All right. Let's see, over there.
How you doing? This is for Jim Free. My name is Jay Castro. I'm from Space Orbit, a site in Brazil. NASA plans to deorbit the ISS in 2030. Can you explain the process, and is there any invaluable item that will be brought back to Earth? Thank you.
Let me let Robyn, as much as I would love to answer that question, the real expert's going to be Robyn. So go ahead, Robyn.
Yeah, sure. So our plan is to deorbit the International Space Station at the end of the decade once we have a commercial space station to replace it in orbit. So that's the plan that we're working to. We now have a contract with SpaceX to develop the vehicle that's going to do that big burn to deorbit the ISS at the end of the decade, and we're calling it the U.S. deorbit vehicle. And so the timeline leading up to that will be, we're going to do operations for as long as possible. Our last crew will stay on board about a year, and then depart the station about 6 months before we actually do that deorbit. And then the deorbit vehicle will be launched, docked to the station, and then do the final burn into an uninhabited part of the ocean, away from any populated areas. So its job is to bring the station home safely. And as far as preserving items, we're taking a look at that. We know that I've worked on the space station my whole career, so I really want to see us bring some things home and put it in the museums as well. We can't bring big pieces home. And we can't really take the station apart. We get asked that. But we can bring some small things home, and we're starting to talk to the Smithsonian about some items that they would like to have. We're also talking about what equipment on board we might be able to bring home in one of our cargo return spacecraft in order to save it. So we are thinking about that.
Okay, great. Over here.
Hi, thank you so much for being here. AJ Blyer from Culver City. I was curious, are there any discussions about testing Starlink on the ISS? Has that been something explored at all?
As far as I know, there have been no discussions about testing Starlink specifically. We do have a number of tech demos that we've done on the ISS for various aspects of comm. We recently tested a laser comm system called Illuma-T over the summer that was very successful, and there are a few more that are planned to be coming up in the future as well.
Maybe I'll just point out too, the Dragon vehicle, SpaceX recently demonstrated for the first time Starlink connection capability on their Polaris Dawn mission, which is something we've been following along as well, and I expect to see on a future Dragon mission. So really excited to see.
Great. I'm actually going to go to a question on social media. So this one, and we'll go down the line, reminding people that we do have 10 minutes, so try to keep your answers pretty succinct. What's one thing you want people to know about the space station? It's very open-ended.
Start with John.
Let's start with John. Oh, look at that. Jim says to start with John. We got to start with John.
I'm the Dragon guy. Well, the Dragon goes to the International Space Station, and we love to go there and see the docked operation. So, the Dragon doesn't just launch and come right back, right? We're docked there for 6 months. The vehicle, it's routinely checked out while it's on orbit, which is always a fun day for my team and I when we go on console, wake the Dragon up, check all the sensors, and then kind of put it back in its lower power quiescent mode. And just to see the crew on board enjoying, what they're doing on station and going into the vehicle and checking it out and keeping it updated. So it's amazing to me that we've got basically continuous missions that last for 6 months at a time, right? Compared to the shuttle days where we were flying for a few weeks at a time. So definitely enjoy that.
And I read this recently, actually, that we can also use these spacecraft as sleeping quarters if we need to, right, Robyn? I believe Mike Hopkins spent his whole 6-month mission sleeping in Dragon, right?
That's right. We have crew quarters on station, but when we have extra crew during these handover periods, then sometimes the crew sleeps in the vehicles they arrive in.
Yeah. So that was a good point to bring up, John. Thank you so much. Okay, Jen, you're in the hot seat.
Yeah, I think today we kind of scratched the surface on a little bit of the science and the benefits that we have from the International Space Station. So I would suggest folks follow us on our social media accounts. We have an ISS research account, as well as we post to the space station account. I personally get a lot of satisfaction seeing the crew engaging with the science, doing science, and it's, I think, a great vehicle for inspiring the next generation as well.
Perfect. That's a great one. Yeah, because there's so much. Again, 200 to 250 every 6 months is how many, science experiments we're talking about. Okay, Robyn.
Well, good segue. Talking about the next generation, one of the things I don't think we've touched on too much today is the education outreach, and that's one of my favorite parts. We reach millions of students every year through educational activities on the space station, be it science demonstrations to story time from space. We have students actually building hardware that goes up. And so we have a lot of programs through the other fact I'd like people to know is that the space station is a national lab. So it's your lab. We have 50% of the resources dedicated to things that other people want to work on. Other government agencies, commercial, and students. And so through the National Lab, we do a lot of these kinds of educational activities.
Awesome. Great.
I would do a shameless plug for our NASA Plus multimedia access because you can go on there and you can see pictures and videos from the crew inside Space Station, and you get a feel for there is no floor or ceiling. They use all 4 sides because they can float around. And you can just get a sense of laptops here for the science, laptops here for the robotic arm. You just get a feel for what it's like to be inside ISS.
Yeah. We definitely will talk about how you can find out more information. That is later on in this broadcast. Okay, go ahead.
Hi, Alice Carew from T-Minus. You've talked a few times about the commercial LEO destination project that's coming after the ISS. Obviously, there's been reports recently that one of your commercial partners is quite behind. Russia hasn't committed beyond 2028 to be able to commit to the ISS. What are the contingency plans for NASA if something goes wrong and you aren't able to get something ready in time for you to deorbit?
Yeah.
Yeah, so we're working really hard with our commercial partners to get a commercial space station by the end of the decade. And so I think our schedules, even though, everything takes longer. And we're seeing that certainly with some of these companies because, you know, when you're developing something new, it generally takes longer. All of our vehicles have taken longer than scheduled, but I think we are still on a path to getting that capability by the end of the decade, and we're committed to doing that so that we can have a transition with no gap. That's the last thing we want, is to break this 23, by then 28, 29-year streak of continuous presence by not having a place to go. So we're working really hard on that, and our commercial partners are doing well. They're making progress. We've got a lot of interested companies out there, and that's exciting to see. And we're going to be, stay tuned, because we're going to be, we just released our LEO microgravity strategy, which outlines our goals and objectives for our future plans in low Earth orbit. And we're excited about that. We're excited about issuing our request for proposals next year and making some awards for the next phase of that development.
And we have time for a question on the phone. This is Jeff Faust, Space News.
Hey, good afternoon. Apologies for maybe what's an ISS 201 or 301 level question, but there was the OIG report yesterday on ISS transition issues, and it noted that there's an increase in the leak rate in the Russian vestibule that had an ongoing leak problem. I was curious if you could provide an update on efforts to resolve that leak and determine at what point the leak becomes untenable and you have to seal that off. Thanks.
Yeah, I can start, and Robyn, feel free to add anything you like. Yeah, we continue to work with our Russian partners, Jeff, on the leak, and they've done some repairs recently, which has dropped the leak rate, and we'll continue to work with them to understand the sources of the leaks and how they affect the operation of the space station. And we're going to have a full press briefing later where others will be on that can probably add to that. But what I tell you is, it is every day we work together to solve technical problems on the space station. Some are easy to solve, some are hard to solve, some we have to work for that technical agreement together, and I'd say what's going on in the Paracas is an example of that.
I'd just add that the recent operations in that segment since that report have actually resulted in a decrease of the leak rate by about a third. So we're continuing to make progress on it.
Everyone, thank you so much. I know there's still so many questions in the room. We only had these folks for 45 minutes, as well as we know our digital content creators have a tour of Kennedy Space Center for the rest of the day. So thank you again to everyone who asked some questions, of course, to our panelists here. We all hope you enjoyed learning about the International Space Station and how it does benefit us all. So if you want even more information about the space station, we do have a QR code that we're going to bring up for those who are watching us here. It's going to take you to the International Space Station webpage, and there you can find so much more information. We really encourage you to do that. There's all sorts of interesting information there, like research opportunities on the orbiting lab, and also how you can spot the station as it flies over your neighborhood. That is really cool, so I encourage you to take a look at that. And then again, remember, we are talking all things space station ahead of Crew-9, so you can follow along with every development by checking on the mission blog. We have that now up on your screen there. You can scan the QR code or just jot down the website, and then, of course, we will have live coverage of the launch right here on NASA Plus. The astronauts will begin suiting up around 9 a.m. for liftoff at 1:17 p.m. Eastern Time tomorrow. We really hope you can join us. Have a great afternoon.